Thank you for coming to this talk today. My name is Abby. I am a developer advocate. I work for IBM in their quantum computing department. Specifically, I work on an open source SDK called Qiskit, which is a Python-based package to help people do development work for real quantum computers. And that is kind of what I'm going to be focusing my talk around a lot today. I'm going to talk more about that open source community, how we manage that open source community. Not going to focus too much on quantum computing as a technology itself. I'm going to focus on some of the challenges we faced in developing a community in this emerging tech space, some of the practical things we've done to overcome them in our open source community specifically. And yeah, hopefully there should be some tips for any of you who maybe you're just starting your own open source package, or you're doing work in a similar area, this kind of intersection between computing and the scientific field. Yeah, so even if you don't have a foundation in quantum, you should still be able to get something useful out of this talk today. That being said, every time I do a talk around Qiskit, people always do have some general questions about quantum computing itself. So here is a nice handy TLDR to kind of give you a little bit of a foundation before we move on to talking more about the software. Quantum computing is a type of computation that is based on the principles of quantum mechanics. There's been research into quantum mechanics itself since the early 1900s, and after that we started developing these kind of theoretical ideas about creating a computer based on these physics principles. But we didn't really have any real devices that could kind of experimentally do these things until around 1998. And it's still a long road to go to actually make these devices useful for their kind of intended original theoretical ideals. The kind of basics of how a quantum computer works, and I do recommend you go and research this a little bit on your own time if you are interested, but instead of using a binary system the same way that classical computers use, quantum computers use quantum bits or qubits. You can kind of think about them as kind of subatomic particles that we manipulate to be able to do calculations. One day we hope that these quantum computers will be able to solve problems that are too complex for classical computers, but at this point in time, there are a lot of challenges to overcome just in the development of the hardware and the technology. There's this idea of noise. Qubits themselves are a lot more fragile than your regular, binary bit. And we have to, put them in these big kind of chandelier type things in like very, very low temperatures just to kind of keep them stable. And this point is going to become important later on when we talk about performance. These qubits themselves will only last for, a couple of seconds max before they actually collapse and become unusable for your computation. So performance becomes a really important aspect when you're developing software for these. Today, you can yourself go and write code and run experiments on real quantum devices using quantum SDKs like Qiskit. Qiskit is an open source toolkit for quantum computing. And essentially what it is a compiler. You write your code in Python, and Qiskit kind of compiles it into something that we can then send to a real quantum device. Okay, now that that kind of background is out the way, we're going to talk about how is Qiskit itself, the software package, developed. There are a lot of different components that kind of feed into the development of this package. The first biggest one, I guess, that I should mention is IBM Quantum itself. IBM is our biggest driver of functionality and capabilities and funding for this package. I work for IBM, so I might be biased here, but IBM does really have the most advanced quantum devices out there on the market right now. So in order for Qiskit as a software package to be able to support the most advanced users of quantum computing, we need to make sure that we have as close a relationship with IBM Quantum as we can, and we're making sure that our software features are kind of keeping up with the developments that they're pushing out on the hardware side as well. And being an actual kind of salaried employee of IBM Quantum while working on Qiskit really helps just in terms of communication and driving that, the mission of Qiskit itself. Aside from that, we also get a lot of input from outside researchers or even researchers within IBM. New research in the field of quantum is coming out all the time. There's a real kind of there's a lot of energy in the space at the moment, lots of papers coming out all the time. And we want to make sure that we in Qiskit are putting out features that can kind of showcase this new research as much as we can. We want to make sure that we are staying on the cutting edge of this cutting edge technology. Aside from that, we also have a lot of just really important code expertise that we kind of bring into the development of Qiskit. It's not just a collection of all these research codes. The fundamental kind of internals of Qiskit needs to be very performance driven, as I mentioned, because when you're sending things to a quantum computer that your computation can only last a couple of seconds, you don't want any other layer of the stack to be the bottleneck there. So Qiskit itself, we have to make sure that we're very, very performant. And to do that, we need a lot of skill sets from classical software developers, compiler developers. We want to make sure that the internals, we've even started rewriting some of it in Rust. So we need a lot of code expertise as well. And the last piece, I'm going to touch on this a little bit next, is this idea of an ecosystem. We also heard about it in the keynote earlier today. But this is about kind of, we have a lot of other entities in the broader community that are building their own packages that kind of extend Qiskit or are built on top of Qiskit. And so we kind of talk about them in terms of this ecosystem, and sometimes we will even kind of merge things in from that ecosystem into Qiskit itself. Okay, so this kind of now I'm going to lead into talking about some of the challenges that we face, partly because of this model. If I want to kind of zoom in for a second on this piece of the puzzle, this is kind of a simplification of how, a metaphor of how this works. For us in Qiskit, development actually used to look a lot more like this. We had a lot of people in the research community who were very, very keen on getting their research into this Qiskit software package. And I think that's one of the unique things about working in a field like quantum computing, or if you're in any kind of field of open source science, is this kind of closeness to academia. And to a certain extent, this relationship is really good because we want to keep up to date with the latest research, like I said. That's part of doing development work in an emerging tech space. And so at the very beginning of our Qiskit development journey, we were kind of just saying yes to everything because we were like, wow, that's a really cool piece of research. Like, let's put it in, let's put that in. The problem is that this kind of ended up clashing a bit, the open source culture with the research culture. For researchers, what we would tend to see is that they would write some code for a paper that they're working on, submit a huge PR to Qiskit, and then, you know, the code quality maybe was a little bit dicey, but, you know, we were keen to have the research, so we would kind of accept it. And then once that pull request got merged in, the people that published that paper, those contributors would kind of disappear. They're moving on to their next research project. They aren't so interested in staying around to maintain this code, and our maintainers had to kind of struggle to maintain it themselves. They didn't have such a good understanding of it. The relationship kind of like fell away once the researcher had moved on to their next project. And that became difficult for us to maintain this in the long term. So our solution, or our attempted solution to this, was to develop this concept called the Qiskit ecosystem. In a lot of ways, it's very similar to the ecosystem that we heard about in the keynote earlier, except instead of being a kind of a natural phenomenon that's occurring, this is a more kind of formal framework or program that we are putting energy into developing. So now, instead of accepting research code straight into Qiskit directly, we first encourage people to join our ecosystem. And this is the kind of the web page, just showing you a little bit of what it looks like. You can go see this at qiskit.org/ecosystem. And the key kind of tenets of this program is that by joining the ecosystem, by submitting a proposal to have your project kind of join it, projects end up getting some recognition from Qiskit itself. We help them to promote their work. We put some we put a little box on the website to show they can showcase their project on our website itself. We invite them to publish blogs on our Medium account. We invite them to present at our demo days. And we're also, as part of this program, trying to provide resources to help the researchers themselves create better open source projects and mature that code. So we also have the ability to run automated tests against Qiskit by joining this ecosystem. We will run nightly tests against your project with different versions of Qiskit. So you can see in real time how compatible a certain version of this ecosystem project is with the core Qiskit package itself. And importantly, this takes a lot of the burden off of the maintainers themselves. They feel much less pressure now to just directly merge code in because a researcher is really kind of pushing for it. Now we can kind of say, okay, first go and go through this ecosystem program. And we hope at some point to be able to mature this program more, develop a more robust pipeline to integrate those projects more into Qiskit itself if that becomes still a valid thing that those researchers want. Possibly they just want to continue staying as their own open source project in the ecosystem, and that's fine too. As of last week, or when I last took this screen grab, I think we had about 41 projects in our community tier of the ecosystem, and we're looking forward to keeping this program growing more and seeing how it develops. So now we've kind of moved from this model to more of this model. Research goes into the ecosystem and then possibly comes into Qiskit itself, or the ecosystem itself benefits. If anyone is interested in a bit more about the kind of philosophy around this, we have an RFC where we're kind of documenting the policy side of this. We also have the main website where you can see all the other projects that we've kind of added to this ecosystem. The next point that I wanted to make about some of the things that we've learned through our open source community journey, kind of leading on from the ecosystem idea itself, is this idea of having clearly defined spaces. This is a really kind of subtle, yet I think really important aspect of community management that requires pretty careful planning. Just as an example, I mean, anyone here who's an open source maintainer, put your hand up if you've ever had someone come to you or to your project with a question or a request, and it was just completely irrelevant. It wasn't the right forum, it wasn't the right person to talk to. I know I've definitely had that experience. Yeah, I see a lot of people have dealt with that. And we were dealing with this problem a lot. And you kind of get forced into two options when this happens. Either you just, kind of feel a bit mean and say, sorry, I can't help you, like this isn't the right place. Or you kind of waste your own time trying to help this person that really wants to be an active member of your community. And having clearly defined spaces, like, for example, Slack channels or using GitHub features, all these different places where you can direct people. First of all, if you have those well documented, then these members of your community hopefully don't get to the wrong places as often. Or if they do come to you and they have something that's they're clearly in the wrong place, you now very quickly have a way to direct them out to the right place and help them get help for whatever they're looking for. These that I've thrown up here are just a few examples of what I would term as kind of a clearly defined space, and making sure that you are documenting each of them and moving people between them, I think, is also really important, making sure there are links to things, documenting readmes that explain stuff. I'm a big fan of GitHub wikis, kind of sprinkling bits of documentation wherever you can throughout your kind of GitHub experience, I think has been beneficial for us at the very least. Even something as simple as having an issue template, so that if someone goes to open an issue in your project, sees a few different templates, and doesn't see one that kind of fits what their need is, hopefully that makes them stop for a minute and think, maybe this isn't the right forum to be putting this feedback or this question. Even events themselves, you could typically define as, you say as a defined space. You have like a certain group of people that can help each other kind of being brought together, and making sure that people are getting to those spaces effectively is something that I think is important to invest time in if you're managing your own open source community. Next, that also then leads me onto a next topic in having nurturing your open source community, which is just kind of being a kind human. Even if you have all these clearly defined spaces and these programs to help your community and people that are getting involved, you will still end up with people that are coming to the wrong place or asking dumb questions or writing bad code. And I think it's very easy for us as maintainers to get frustrated with contributors that maybe obviously don't know what they're doing or haven't read the documentation available. And I want to be clear, it's not necessarily our responsibility to hold the hands of every contributor that don't necessarily have the required skills. But I think it really is our responsibility to treat everyone with respect who comes to that community and have some empathy. On the other side of that coin, people who have a negative experience trying to contribute to your project can give a bad impression to the project itself as a whole. And this is especially true, this can put off people from open source in general, and is especially true for people in marginalized communities who anyway don't always feel the most welcome to begin with. So the number one thing that you can do to address this is, first of all, as a foundation, have a code of conduct. Hopefully this is not news to anyone, but I feel like I just need to mention it to like kind of set the groundwork. Make sure you have one. Make sure you have a process to enforce it if you ever need it. Hopefully you don't ever need it, but it's good to have one if you do. Make sure you're holding your own team and your community accountable to what's in your code of conduct. Aside from that, there are a couple of other like neat tips and tricks that I've learned over the years that are very simple things that you can start doing today. First one is, just say thank you. The number of times I've kind of been in an open source community and I'm reading a PR and, it's, even if the PR is not good or the question is, irrelevant, it doesn't hurt to just say thank you. Oh, thank you for getting involved. Thank you for volunteering. Thank you for your contribution. And also don't be afraid to tell people if they did something good. Especially in this kind of PR mechanism, we get really into this mindset of, oh, I need to look for what's wrong and what do I need to fix. It doesn't take, that long to just write a nice message saying, oh, I really liked how you approached this snippet of code or something. It doesn't cost anything to be a nice person, basically. If a contributor is struggling, also recognize, is it because they are generally kind of doing stuff that isn't good enough, or is the documentation that you have provided to them or the processes that you have not set up to support them well enough? Recognize that we have our own kind of ways that we can, be better and improve our own processes to help contributors succeed. Reread your comment before you hit send as well. Sometimes it's very easy to get sucked into the heat of the moment and just like write something and hit send. Just take an extra second to pause, reread, at least check for typos, and think, do I sound like an asshole right now? If you do, take a few breaths and, before going back and rewriting your comment. This is like such a simple thing that you could just like today start baking into your practices of doing code reviews. Also, don't be afraid to apologize when you're wrong. I have a nice snippet here from one of my colleagues who, I was very impressed when I saw this. They actually, they felt like they came across too curtly, and then they also, directly apologized to the contributor. This is just how to be a good person. Just treat others how you would like to be treated. I probably sound like your mother right now, but it is just, some of these simple things can really change the tone of your entire contribution experience and make your community a much more inclusive and fun place to be in. Lastly, I'm always a big fan of emojis. I think they can help just add more fun back into your community experience. I know we're kind of getting close to time a little bit, so I'm going to move quite quickly on through the next sections. Automations have really helped us to speed up our contribution kind of pipelines. We use bots all the time. We do bots for code coverage. We have Mergify. We do CLA bots. We also have our own custom Qiskit bot, which will kind of spit out a message when someone opens a PR, explaining the process to them, what their next steps are, tagging the relevant code owners. We even add specific tags for community PRs, so we know which pull requests are coming from people outside of our core maintainer team, because those are the pull requests that often we tended to kind of fall off the radar. So now we have a better way of tracking this, and then we use things like GitHub projects. We have a contributor monitoring dashboard specifically targeted at helping to triage those community pull requests that aren't getting, always top of mind in our maintainer dev meetings. This has become a really helpful tool with us. We even, do this with the GitHub Good First issues and Help Wanted issues. We triage them as well with GitHub projects. Really useful tool. One of the last points I want to make is about this intersection of development and developer relations. I am a developer advocate. My field is developer relations. If you're not aware of what that field is, basically you can sum it up in these three segments: code, content, and community. I really recommend bringing on a developer advocate or a developer relations person, community manager, whatever you want to call it, into your core maintainer team if you have the resources to do so. You know, these people that you bring on, their sole job is to help the open source community thrive. A lot of the things that I've said take a lot of time to develop and to put these processes in place. And sometimes the core maintainers, you know, you don't always have the time to do all of these wonderful things. That's why bringing on someone like a developer advocate can be really beneficial. They're probably not going to be someone who contributes major features to the project themselves, but they should be skilled enough to help others in the community be productive and help the overall health of the open source community. The very last thing I want to talk about, the community management graveyard. A lot of the things I've talked to you about are things that we kind of have succeeded at, but there are a lot of things that we have tried and did not work out that well. And I wanted to just take a moment to, you know, in somber remembrance of the things we tried and failed, and to recognize that part of being an open source is getting to experiment and iterate, and that is just as true for the whole community as it is the code that we write ourselves. Hacktoberfest was something, I think this is probably not a surprise to many. We found this particularly difficult for our specific community because in order to contribute to Qiskit, you kind of need to have either pretty strong Python skills or pretty strong quantum computing knowledge, ideally a bit of both. And we weren't attracting people with significant, even to do like the most basic good first issues, you have to be pretty advanced in one of those two areas. And Hacktoberfest, we just weren't attracting the right kind of people through that. We've now moved to do a program called Unitary Hack, which is a little bit more focused on the quantum computing community, which has helped us a lot kind of do the same type of thing. Next up, GitHub discussions. I'm not sure I'm completely ready to give up on this one completely, but when GitHub first launched this feature, we were really excited. We could like have a discussion forum in our repos, but I think when we were looking at this and seeing how successful it was in projects like GitHub or NPM had used these very well, they were just much, much bigger projects than we were. Like, we are still a relatively niche project, and people aren't as like active in the discussions as, you know, we are when you have like so many millions of people downloading your project and we only have, you know, a few thousands. The last one is YouTube live contributing, which is one I was just thinking about recently because, you know, we had this idea to like live stream the contribution process, which is actually really, really dry. It's not an enjoyable thing to watch. It's barely an enjoyable thing to do when you're like waiting for your build to run and it's like 20 minutes in and you're having to ad lib with like the 3 people on the live stream. So maybe YouTube just wasn't the right platform. Maybe we just give up on this one. But yeah, this one did not work out in terms of generating, you know, interest in the contribution experience. All right, that's it from me. I'm just going to leave up this last slide while we take questions. If anyone is interested in getting involved in contributing to Qiskit itself, these are some of the recommended ways that I recommend. So take a photo of this if you want. Google it while we're taking questions. Yeah, I'm just going to leave that there. Okay. Thanks, guys.
Thank you for the great talk, Abby. So I'm a quantum engineer at Microsoft, and I worked on the Azure Quantum team before, and I worked on actually integrating Qiskit into our stack. So I'm pretty familiar with your code base. It's pretty. I was just curious. So you talked a lot about Qiskit and kind of about the community around that, but there's also a whole a group, I think, working on quantum assembly, like QASM 3.0. Yeah. I was wondering if you can share a bit about like how that's going and like, because I believe there's a few different companies involved with that.
Yeah, for sure. Yeah, that's a really interesting one. So if you imagine kind of Qiskit sits at, the highest level of the stack, this like Python interface that people use, the kind of the layer below that, when we compile it, we need to compile it down into something. And Chasm, quantum assembly language, is one of those things that we are compiling stuff down to then be able to run it on the real hardware. And Chasm itself is also an open source project. It is driven a lot by IBM Quantum as well, but like you say, we do also have members from other companies doing quantum work involved in the contribution there. So we do affiliate it with Qiskit as part of the kind of a very high-profile part of the Qiskit ecosystem in general, but it's not Qiskit itself. It's something that Qiskit interacts with. And yeah, like you say, there's a lot more parties involved from other companies, so we also don't want to necessarily attach Qiskit as the brand too closely to it. Yeah, and that they have a slightly different, there again, like if Qiskit is a small package, like Chasm is like an even smaller kind of open source community, they have a much more kind of, I think, a structured open source process. They operate more a little bit closer to like a federation type of thing. They have a whole kind of committee structure. Qiskit doesn't have that same structure. We have a different style.
Okay, so it's interesting what works and what doesn't work, because one of the graves was to GitHub discussions, which has been very useful for us. Mm-hmm. Meanwhile, we haven't been able to get anybody involved in GitHub wikis. Mm-hmm. So it's kind of the opposite. So with the GitHub discussions, the reason that it's worked well for us is the first level of like misunderstanding when you have someone from outside and not really sure what they want to ask. The thing that they're usually confused about is whether they are looking at a usage question or a bug.
Yeah.
And so, being able to take something from an issue and turn it into a discussion, from a discussion turn it into an issue, because the user misclassified it, that's been really useful. The only thing where we found limiting with GitHub discussions that is bound to one repo, and sometimes we want to talk about things that cross repos. And in principle, we could do that with org level discussions, which just haven't yet. But if there could be some way to understand why one of these technologies works for one group and not for another, I'd like to know.
Yeah, no, I think that's a really good point. And actually, I should have mentioned this. What I'm explaining is what worked for us in our project, but every project is different. You have a different group of people, a different type of user, a different type of maintainer, and a lot of it, I think, is going to just come down to you have to experiment with what works for your community. And what works for us might not necessarily work for you. I think in general there are some best practices, but then like the mechanisms and like the intentions that you're bringing, the mechanisms in how you do them maybe differ. For example, for us, like we have a very dedicated space in Slack for usage questions. So people come to our GitHub discussions where we really want to, and it kind of creates noise when we actually want to use GitHub discussions for like development discussions. So that's kind of where I was mentioning this idea of having clearly defined spaces and making sure that people are getting directed to the right ones. And also doing that with empathy, not just ignoring someone because they're saying the question in the wrong place. Be like, hey, this looks like something that should go in our Slack. Here's a link to join our Slack. That is kind of, I think, the best mechanism for migrating people across. And I think this could also work for discussions across repos as well. Don't underestimate the power of just adding a link to direct somewhere to a better place for something. That is, you're already helping them, even if while simultaneously taking a step back from it as well. In terms of understanding how things work in one situation and not another, I don't think there is some general rule or formula that people can use. I guess in general, just kind of listen to what your users need, what your contributors need, and try to execute what you're doing with empathy. Put yourself into the shoes of your audience and try to kind of serve them as best you can is, I guess, the only general principle I would say that works across everything.
Thank you. There is one more last question. This is also on Slack.
Yeah, sorry, I hope I didn't double dip. I wasn't sure how the question part works.
Not at all.
I have a question about the ecosystem part.
Yes.
So once something join the ecosystem, and as you say, researcher can just go away and do other stuff.
Yep.
So when that happens, that piece that they contributed to the ecosystem, do they then fall out of the ecosystem? And if so, what criteria do you use?
Not necessarily. Or at least we haven't, this is still a relatively new program, so we don't have a kind of a timeline or an enforcement level. But part of the reason why we added this kind of testing feature was that people can, to kind of add some transparency to the process, so people can go and they can use the Qiskit website to find a certain package that they're interested in the ecosystem. And if they have if we have gotten the testing things enabled, they can go and see, oh, like this project doesn't work with the latest version of Qiskit. That kind of gives a little bit of a indication that maybe this package is not as well maintained as like the user might like. But we still kind of have it there because maybe they still want to go and see the source code of this project, and maybe this person looking at the project might be a future maintainer that could join that project and then revive it. So we don't want to just kind of eliminate projects from the ecosystem, at least not yet. Maybe this will change in future if it becomes like we have too many projects with us. But at the moment, our goals are to help provide a platform for researchers to share their research code, help them make that code, to a higher quality standard, help them attract users, and also help them attract other contributors. Yeah, does that answer the question?
And let's thank our speaker again and switch over to the next one.